Thanks for coming here today. My name is Mohammed Nufal, and I work as a solution architect in a team called the Global Black Belt team in Azure. This team is a team focused on technology verticals, and my technology vertical is cloud-native compute and apps on Azure, which primarily translates to Kubernetes nowadays, right? In my line of work, I work directly with customers to help them better deploy, architect, operate their Kubernetes clusters on Azure. This session today is about applying best practices on Azure Kubernetes Service. The focus would be into two topics, high availability and cluster management. As in this session description, this session is 300-level session, which means that the assumption that you already have the basic knowledge of Kubernetes and basic knowledge of AKS, right? If it's not the case, then it's going to be a bit difficult for you to follow on the session because I assume that the knowledge is there. Now, just to set the stage, who has Kubernetes cluster running in Azure somewhere? Awesomeness. And out of these, which is AKS? Very good. And out of these, who are in production? Very good. OK, we are all in the right place. Awesome. Right, so this session is a continuation for an effort we started in the last Ignite under the same name, applying best practices to AKS. This session, the last Ignite, was focused on network and security. So if you are interested in network and security best practices, most of the recommendations remain the same until now. So you can go and check this URL there. So our agenda is pretty simple. We have two topics. The first topic is how you can build for high availability, business continuity plan, disaster recovery in mind. So that's the first topic. The second topic will be cluster management. I'll be mostly focused on how you should do cluster upgrades, right? Now, one thing that I learned from delivering this in different venues is that I'll never finish on time. That's a fact. So what I did is I got a bit excited, so I added a lot of content. There's a lot of things that I want to share with you today. However, I'll not be able to go through all of them. So what I did, I created a public GitHub repository where I dumped all the demos that I want to do, all the transcript, and all the slides in there, right? So I'll share this with you towards the end of the day. So the things that we didn't go through today, you're going to find them in this repository, right? I'm not going to share it now because you're not going to listen to me, so yeah. Right. So high availability. Very quick reminder on the Kubernetes architecture, right? Kubernetes architecture has two main components, right? The first component is the control plane, and the control plane is basically where the API server is running. This is what you as an operator interact with to manage the cluster. So you scale, you deploy, you do all the management operations are being done through the API server or the control plane, right? And then the other component is called the worker nodes. And the worker nodes, this is where your workloads are running, right? So this is where the pods are running, and this is where your application is running, right? So as such, each component serves a different purpose, and we need to think of them when it comes to availability differently, right? And this is what I'm going to do throughout the coming section. Right. So talking about the masters and control plane, what do we offer in AKS when it comes to the masters and control plane, right? Today, we offer an SLO, service level objective, on 295 or 99.5 availability. The reason this is an SLO, not an SLA, because you're not paying anything for the managed service. As such, we cannot financially back you up in case something has happened, right? So this is why it's not an SLA, right? Now, what happens if the masters went down, right? The only thing that you'll not be able to do is to manage the cluster. So you cannot deploy new deployments. You cannot scale your existing deployments. However, your application remains running in its last known state to the API server. So the application is not impacted by the failure of the control plane, right? And that's very important, right? So there is a room of improvement. So how are we going to improve this? There is a planned premium SKU for AKS coming before the end of the year, where we're going to introduce high availability to the AKS masters or the control plane, and it's going to be premium, right? And there will be also an SLA. The other thing that you can do is having multiple clusters. This is rarely to improve the availability of the masters. So I've seen customers doing it, but for different reasons, to improve the availability of the applications. And the improved availability of the masters comes as a byproduct from having multiple servers, right? So don't do multiple servers just for the masters or just for the control plane. Cool. So that's enough with the masters. I'm going to go and focus on the applications now. So the nodes, where the application is running and where our workloads and where it matters, right? So what do we offer in AKS? Right. Cool. So AKS follows the Azure Virtual Machine SLA, right? Which means that if you have your AKS cluster running in a virtual machine scaling set, which is the default now, or virtual machine availability set, which was originally how AKS used to work, you're going to have 99.95 of availability SLA in AKS, right? Now, new, we added availability zones, and I'm going to cover this in depth. If you have your cluster in availability zone, you're going to have 4 nines, 99.99 of availability, right? Now, these are great numbers. However, there is still a big room for improvement, right? So this is now the focus of the coming slides. Right, so let me introduce you to our simple application that we're going to work with in order to improve the availability for, right? It's a pretty simple application, 2-tier application. It starts from the backend for some reason, right? So it's a backend app running an API or whatever, and then the database is a MySQL database running as a Kubernetes stateful set, right? So backend app and a database, it writes to the database, right? Both are running an AKS cluster. The image for the application is hosted in Azure Container Registry, and the cluster is fronted by Azure Standard Load Balancer, right? The simplest of applications, 2-tier application, right? Now, when we think of the availability for this application, what are the considerations, right? So many things can go wrong, right? The cluster itself, the state, if we have state inside the cluster, which we do in the MySQL, the region, the surrounding services, the SLB, the ALB, and so on, the registry itself, the sessions, and so on. So for the simplest of applications, we have so many things to consider when it comes to availability, right? So let's try and cover these. Now, when we think of availability, we have different options, right? It starts from the top, and that's how we think of like business continuity plans and so on. It starts from having a backup and restore, right? This is where you should absolutely start from. Then availability zones, then multiple clusters within region, then finally multiple clusters across regions, right? I hope we are in an availability session, so I hope everybody knows what RTO and RPO are. So RTO, return time objective, and RPO, return point objective. This means how much time we can tolerate to return our clusters and to which point of time we can return our data, right? So as you go down, you're going to get the best RTO and RPO, but you're going to get higher, you're going to get more complexity and more cost in the process. So the sum of this slide is the higher availability that you can cater for, the more cost and the more complexity that you're going to cater for, right? Let's take these one by one. Right, so backup and restore. The goal from having a backup and restore is, in case of failure, we need to be able to restore our cluster into a good known state. Pretty simple, right? Now, if your clusters are stateless, congrats, right? There is less work to do. All you need to do is just redeploy your cluster. Off you go. That's it, right? Now, if you have state, your cluster is no longer the same, right? You have to take more care of your cluster. You have to manage for the state. You have to cater for the state, and so on. And this is the focus. Right. So now, both scenarios, stateless or stateful, I'll be having this assumption, and this is where you should absolutely start from, assuming that you don't or you're not. You should have your cluster deployment as part of a pipeline. You should have your application deployment as part of a pipeline. So infrastructure as code and CI/CD pipelines for your application. If that's not the case for you, go and do that now. This is where you start. If that's not the case, then your business continuity plan is only good on paper, right? So it's not going to work. Now, what about the state? How can we handle the state? Okay. So restoring the state. Now, we have two states for our applications. The first state is the application files, and these are, think of them as the application binaries, the binaries that are required to run your application, right? And the assumption here is, because you have container images, your binaries are already in the container image, and you're going to cater for their availability in the container registry itself, right? It's pretty simple. And then the other important part is the application data itself. So we have a MySQL database that is storing data. And that's the application data, right? Now, the assumption as well is you're using Azure disks for the state, right? If you are using Azure File is pretty easy. You snapshot the Azure file. You have an always-on snapshot for the Azure file, and then in case of failure, you just remount the mount point for Azure file. Disks are a bit more complex, and this is the focus in here, right? So in order to snapshot disks in Azure, you have 2 ways, or different options, but the two most popular ones. The first one is the first-party one, which is using the Azure Snapshot API, right? Now, there is a problem with the Azure Snapshot API is that it's not Kubernetes native, right? It doesn't really understand this disk belongs to which deployment, right? So we can snapshot a disk, but we don't know where does this disk belong to, right? We can restore the disk, but we don't know where to restore it to. So we're just going to restore a disk. You're going to have to go and find the disk one and then go and mount it manually inside the Kubernetes cluster, right? So there is a manual process involved if you're going to use the Azure Snapshot API, right? Now, the other option that you have is something called Heptio Arc or VMware Valero. That's an open source project, right? And it's a native Kubernetes backup and restore and migration tool, right? Let me try to demo this for you. I have so many demos, so I decided to mix a bit between videos, and which I absolutely hate. But yeah, I'm going to do this one in video because it's long. Right. So what I have here is I installed Valero on the cluster. So Valero is basically a binary or pod that gets installed in your cluster. The configuration is pretty simple. Again, everything is in the repository and how you can install this. The configuration for Valero is just Valero, hey, do my backups on an Azure storage account in this blob container, right? That's all there is. So it's going to dump all the backups to an Azure storage account. That's the configuration that I've done for Valero, right? And then there is the Valero client. That's something running on my machine, right? So to do the backups, right? And now I have my application, right? It's MySQL, and it's running in a namespace called Ignite. Right? This MySQL is running as part of a stateful set inside Kubernetes, and it has a persistent volume that is mounted under this namespace, right? So that's a disk. Now, I'm simulating a front-end application. This front-end application is a MySQL client, right? And what I'm doing is I'm creating a database, and I'm just creating a record inside the database called Hello Ignite, right? So I just wrote a record to my database, right? Now, let's make sure that the record is there. I'm going to use the same pod exactly to do that. Right? So the record is there. Now, what we're going to do is we're going to backup the namespace. So this is what I'm doing now, backup, create, ignite v1, and include the namespace. So what I did in here is I backed up the whole namespace. Right? So everything in this namespace, I backed it up. Right? So if I describe the backup, after a while, the backup is completed, right? Now, what happened in the background is Valero went and dumped a backup for me in an Azure storage account, right? So this is the Azure storage account that I created for Valero, right? And there is a blob container that I already created for Valero as well. Inside this, you can find the backups. There is the backup v1. And what these are, this is the mapping. Right? So what Valero did in here is just it created the mapping for me. This is the namespace. This is everything that is running in the namespace. These are the snapshots. These are the disks and where they belong to. So now we have the mapping somewhere. We don't have to understand the mapping ourselves or do the mapping manually for us, right? So that's the first part of it. The second part is the disk snapshot itself, right? And if you know AKS, then you know that there is an infrastructure resource group that we create. So I'm going to the infrastructure resource group, and in the infrastructure resource group, I have this snapshot, right? Let me pause a little bit in here, right? So we did a snapshot with the mapping, and we created the disk snapshot inside the resource group. We shouldn't stop in there. We should be able to copy this snapshot to some other region as well, right? Because if the region went down, we need to be able to go and restore our data somewhere else, right? So keep that in mind. Right, so now I'm a bit ambitious. I'm going to delete the namespace. Don't try this at home, right? So yeah. So it's going to take a while to delete the namespace because there is a disk. Come on. Even NVIDIA is slow. Right. So the namespace got deleted. If I get the namespaces, there is no namespace now. We're out of business. So I'm going to restore now, right? I'm going to restore this state from Valero, right? Sorry. So if I just get this restore, the restores that I had, so this is one restore, and then it's working. If I get the pods, after like 5, 10 minutes, the pods are working. If I try to run the same MySQL client again, try to get the records, boom, boom. Hello. Yeah. So that's working, right? So that's basically the idea. You should have a backup and restore policy. Valero helps you with having this as a automated process, right? Let me switch back to the presentation. Again, everything is in the repository with details on how you should do that, right? OK. We mentioned that you should copy your snapshots or your disk snapshots to some other region, right? Now, there is a limitation in the Azure Snapshot API as well, is that there is no native API to copy snapshots to other region, right? There is a PowerShell module to do that. So go and use this one in order to automate the backups or shipping the backups from other region. And also go and bug the storage team in order to have a first-party API to do that, right? Right, so we did the demo. Come on. Right, so if you are interested in having a first-party solution in Azure Backup in order to do something similar to Valero, please scan this QR code. This QR code will guide you to a survey, and you fill the survey, and then you're going to influence how we're going to build this first-party solution. So please go and fill this survey. You're going to help us understand how we should build a first-party service to help you reduce the tools that you're going to use with this AKS thingy, right? Cool. Availability zones. This is the thing that I'm most excited about. Right. So if you don't know what availability zones are a distinct location, physical location within an Azure region. This distinct physical location has one-to-many data centers, right? And every region, with the regions that have availability zones, has multiple distinct locations like this one, right? And there is a specific distance between the availability zones. With this specific distance, we can achieve 4 nines of availability, right? So now the maximum availability for a workload within a region jumps from 99.95 to 99.99 with doing availability zones, right? Which is pretty significant. Now, things that you need to understand with availability zones is that disks, for instance, are AZ bound. So you cannot mount the same disk across 3 different AZs, right? And then you have to use Azure Standard Load Balancer for availability zones to work, right? Azure Standard Load Balancers also offer 4 nines of availability. It's faster than, it's better than anything that the Azure Basic Load Balancer does, right? So use this one as well. Right. So how would our application look like if we have availability zones? Pretty simple. We're going to have the nodes spread across 3 different availability zones, and we're going to have the pods spread across 3 different availability zones, right? So let me demo this for you. Let me demo this for you. Right. So I do have a cluster. Is it clear at the back? Can you see it? So I'll just switch this cluster. If I get the nodes, so I have 3 nodes cluster, right? Now, I want to check how these nodes are spread across availability zones. So I have 3 nodes, right? Let me do this. Each one of them is in availability zone in West Europe. So West Europe 1, 2, and 3, right? What this is a label, failure-domain beta Kubernetes zone. This is a label that gets added automatically from the cloud provider. What this does is that it instructs the kube scheduler. So the kube scheduler is the component that schedules the pods on your nodes. It instructs it and tells it, hey, your spreading behavior now should consider AZs. Should consider availability zones. It's no longer just local to one AZ, right? So that's the first thing. The second thing, Kube-Scheduler, by default, will make sure that your workloads are evenly distributed across the AZs, right? It's going to do its best to make sure that this is happening. Now, this is under the assumption that it's heterogeneous VMs, so all the VMs have the same SKU and have the same load, basically, right? So if that's the case, you're going to have even distribution across all your AZs. Let's try this out, right? So I'm going to run pretty simple application from an Nginx demo and 6 replicas, right? OK, it's there. If I get the pods for this. Right. So the pods 2, 0, 1, 0, 1, 0. So 2 has some other workloads, so it didn't get all the pods. But there is some sort of distribution across the different AZs, right? So now I have the 6 replicas distributed across 3 different nodes, right? Now, what if we need to influence how the scheduler, how it works, right? So I have a backend application, and I have a front-end application, back to our application. And my backup application, we need it to live within 2 AZs only, right? I need it to live in AZ1 and AZ2. And my front-end application, because it's very chatty, right, to the backend, I need it to be where the backend is, right? So this is my backend application. Pretty simple deployment. So our deployment Nginx, right? But this is the important part. I'm creating a node affinity, again, based on the same label that we added. And what I'm saying in here, hey, go and deploy in West Europe 1 and 2, right? And then in my front-end application, I created something called pod affinity. The pod affinity is different to the node affinity, where it follows deployments. It doesn't follow nodes, right? So the same thing for my pod, our front end. But here, I have pod affinity, right? And what I'm saying is, go and find this label and the backend, and then the topology key is this. So what this will do is it's going to follow my deployment, right? The reason why you would need to do this is you should be conscious of the fact that cross-AZ traffic is charged, right? It's not free, right? So if you need to reduce chattiness, you have to cater for such scenarios, right? So you need to reduce the cross-AZ traffic. But again, the higher availability, the higher the cost, right? So let me demo this, right? So let's create the first application. And the front end, right? So if I go and check on the back end, sorry, let me do this. So the backend now is in VMS as 0 and 1, right? So 0 is in West Europe 1, and 1 is in West Europe 2. So that's done. Now let's check the front end. Front end should be in the same nodes, right? So it's in 1 and 0 as well. So it followed the backend, right? So that is how you can influence the scheduler to your needs, right? Pretty simple, straightforward, but also very powerful. OK, so that's AZs for you, right? So now you may need more than 4 nines if you have availability zones already. Or your region could not have AZs, right? So what can you do? So the first option that you can do is having multiple clusters within the same region. What this scenario will help you with is just to reduce the failure rate of human errors. So it's going to protect you from human errors only. It doesn't protect you from, for instance, region failures, right? And in this example, what I did, the first thing, if you notice, I externalized the state. Right? So the state now is, instead of having the state within an AKS cluster as stateful set, I have it in an Azure MySQL. The reason being, one, is that stateful sets in Kubernetes upstream do not span clusters. So once you think multi-clusters, the stateful set will not work for you. And luckily enough, I have a managed service in Azure that does that. Second thing, it's not fun to manage databases, right? So if you have someone to manage this for you, go and do it, right? Don't do this on your own, right? So what I did in here is I created in Azure MySQL master and a read replica, and then another read replica where the other cluster will read from, right? So the first cluster will read, write, and then the second cluster will just read, right? This is less popular, but it is something that customers can do, right? Now, the other option that you can do is, of course, I'm fronting this from an Azure Traffic Manager in order to distribute the traffic across 2 different endpoints. Right. So now let's move to the other scenario where we have hot multi-region, right? So this hot multi-region is, I have 2 regions now, 2 different clusters. Azure MySQL today, I have a master, read replica in region 1. And in region 2, Azure MySQL today supports having cross-region read replicas, right? So I shipped the cross-region to the other region, right? So now the state is there. And what I can do with this scenario is I can achieve read-write to 1 region and then read to only 1 region, right? The reason why it's not write-write to 2 regions is that because this is relational databases. This is the never-ending challenge with having ACID transactions on databases, right? So you cannot achieve multi-region ACID transaction on write-write, right? There is some ways to do it, but you're going to pay all your money for it, right? So when it comes to the container registry, what you can do is you can have geo-replication on the container registry. That's a feature in Azure Container Registry. Or you can just deploy your containers twice, right? So you can use either option, right? One more option is if you want to reduce the cost, is have exactly the same setup, but you can have a scaled down cluster in the other region, right? So the cluster is not up and running. You don't want to save. So always there is one active. And if, in case of failure, we're going to just scale out the cluster that is in the passive region. Or the cluster that doesn't exist even. And in case of failure, we go and spin up the cluster from scratch, right? The most important thing is, of course, the state to be there, right? This is the best idea that I came up with for a scaled down cluster, this one point. PowerPoint is not my best feature. Right, so what if we need active-active, right? Active-active, write-write across regions, right? If we're going to do this, we need to rethink of how we do things, right? And this is where we're going to consider things like NoSQL, right? And in NoSQL, we do have a managed NoSQL database in Cosmos database. And Cosmos database today have multi-writes master across region, right? Which is pretty powerful. And we can make use of this, right? You cannot achieve this, sadly, on a relational database because it's not the way it works, right? Let me do a quick demo for you on this one. Again, for the MySQL database, I have a dump also for how you can do it, and the GitHub repository, and this as well. Right, so what I have in here. OK, Cosmos demo. Cosmos. No. I have 2 clusters. So this is the first one. It lives in Western Europe with a pod. So what the application, this application is a pretty simple application. So a colleague of mine called Rasmus helped me build it. So it's a cat upload and viewing application. So we can upload cats and view cats, right? That's all there is, right? And it does this to a Cosmos database eventually, right? So we have this pod in Western Europe, and this pod is, there is a service for this pod, and it's represented from this endpoint, right? Exactly the same is repeated in North Europe, right? So that's the pod design again. Right? And then there is another IP for it. OK? So 2 endpoints, 2 different regions. What I've done on Cosmos is this. So if I go to Cosmos, this one, right? Replicate data globally, and I enabled multi-region writes. And then I have West Europe and North Europe, right? And this is basically my endpoint, right, for Cosmos. If I go back to VS Code just to show you, so this is the application. So exactly the same version of the application. It writes to one endpoint, and I have to I need to specify the endpoint for Cosmos and then the key for Cosmos, right? So that's the application itself. If we're going to check the data explorer, right? So we have no data in there. So it's pretty empty, OK? The other thing that I've done is, because now I have 2 different endpoints, I need a global load balancing of sort, right? So I created a Azure Traffic Manager profile, and Azure Traffic Manager is a global load balancer, right? In this Azure Traffic Manager profile, I have 2 endpoints. First endpoint is the north, right? And it points to the public IP of the service. And the second endpoint is the west, right? Pretty simple. Let me take this. By the way, if you're going to try this, try it on Safari. Don't try it on Chrome, because we didn't fix the mixed content on Node.js. That's something I'm going to fix later. Anyway, so let's go to Safari. Right, so that's the application, Cosmos Cats. Right? We're going to add cats. It's a pretty one. Right? What's happening now, I have no idea where am I writing to, right? There are 2 endpoints in 2 different parts of Europe. There's a single endpoint, and I'm just deploying and viewing to them. As a user, I don't know where I'm writing to or what I'm reading from, right? So that's a single endpoint that tries to do different clusters to do different endpoints of Cosmos, right? What happened in the background is that's Cosmos. If I go to data, not this, Data Explorer. If I go there, sorry, items. Yeah, I have 3 items now. So that's the power of having something like Cosmos inside your architecture, right? Good. So that's another one. Doing really bad on time, that's for sure. OK, cool. So that's multi-region. OK, what I want to make you aware of is, so these are the 9s of availability. You keep hearing the 9s, right? So I just want to check the difference between 4 9s and 5 9s, right? The difference between them is literally 47 minutes of downtime a year, right? So the work that you require to go multi-region, what you're going to get out of it is 47 minutes more availability a year. So always be conscious that you're going to be working for months in order to get more 47 minutes a year, right, for multi-region. Multi-region is hard. Make sure that you narrow down the type of application that requires this, right, because it's a lot of work. 99.99 is where most of your applications will land in times of availability, right? Just make sure that you have backups, restores, and you can backup or you can restore in some other region, and that's that, right? OK, so takeaways. Availability is complex, right? So I think we all agree on this one now. Everything as code is where you start from, right? This is where you should absolutely start from, is everything as code, right? Deployments of the clusters and the applications. Then backup and restore. Have a backup and restore policy and plan. Third, if there is AZs available in your region, use them. Last, if you don't have AZs, or you have AZs but you need more availability, consider multi-region. Your challenge is always the state. AKS just works, right? As you see, like AKS is just, think of it as just VMs, right? It's just going to work, right? Your challenge is always the state. Very good. Cool, 12 minutes. So let's move now to cluster management. By the way, availability zones went GA this week. Yay. Forgot to say that. Like everybody from product room told me to say that. But yeah. All right, cool. Multiple node pools. This also went GA this week. And multiple node pools is a feature that helps you with having different VM SKUs under the same cluster. So you can have GPU nodes and memory optimized node under the same control plane, right? So this is pretty awesome. However, the way I think of it, there is some other part or some other benefits out of using multi-node pools, which is the most important one is we decoupled the management APIs from the control plane and the data plane or the worker nodes. So now you can upgrade the control plane by itself only and then upgrade the nodes, right? So you can decouple this operation, right? Scaling, you can have scaling on node pools level. So you can scale one, auto-scale other, and so on. That works. You can have up to 8 node pools within a cluster. Each node pool can have 50 nodes, and that sums up to 400 nodes within a cluster. That's a soft limit. If you have a use case for bigger than this, let us know, right? Cool. Being cautious of time, I'm just going to focus on cluster upgrades now. Although AKS is a managed service, however, you as a customer still hold some responsibilities, right? The first responsibility that you have is to reboot the nodes in case a security patch requires this, right? So we push the security patches on a nightly schedule for you. However, if there is a reboot required, you need to reboot this. And then the second thing is you need to cater for the Kubernetes version upgrades, right? So if there is a new version of Kubernetes, you have to go and upgrade it to your own, right? 1 second in here, use Cured in order to orchestrate the reboots across the nodes, right? So Cured. That's in the repo. I'm not going to focus there. The most important part is the Kubernetes upgrades. So Kubernetes upgrades, right? How we used to do it before. We had an AKS update API, right, or upgrade API. What we did is we said, this is the cluster, this is the resource group, this is the new Kubernetes version, right? What we did in the background, first we went to the control plane, updated the control plane, then we moved to the nodes, We took each node by its own. We cordon and drain the node, so we mark it off scheduling. We replace this node by a new node, and then we move on to the second node, third node, and so on, right? Now, this process is the least amount of work that you can do, because we're going to handle everything for you. However, there are drawbacks for this process, right? The first drawback is, assuming that your cluster is big, right? So you have 20, 100 node cluster, right? And each node will take 5 minutes. An upgrade process can take a day for you, right? So the upgrade process can be lengthy. That's one drawback. The second drawback, it can fail, right? As everything else in this industry, it can fail, right? And it can leave your cluster in unwanted state, right? To be polite. Right, so how can we work around this, right? So we have the ability to do blue-green cluster upgrades on NodePools, right? So if we have a mission-critical type of workload, we should cater for some other means. So let me also demo this for you. Please, 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 yes. It's going to be video because it's lengthy as well. Right. So I have this cluster, AKS Ignite NE. I'm going to get the nodes. I have 2 nodes cluster running 1.13.11 of Kubernetes version, right? Now, if I show the labels, there is a label that was added also from Azure called agent NodePool NodePool 1. So that's the NodePool name that I have inside my cluster. Okay. So I have a simple application as well. The application is my app. It's called my app, and then it has a label called app equal my app v1, right? Okay, I'm going to deploy the application and create a service for the application. Right, so the container is creating. If I get the service, so now I have a front end or I have an endpoint for my application. All the endpoints are the pods for this application, so that they're there, right? Now, if I'm going to go and get the upgrades and see if there is a new version available for me, then there is, right? So there is 1.14.8 of Kubernetes, and I need to upgrade to this one, right? So now what I've done down, right, there is a loop, curl, on the endpoint that I created to check if the application is working. It only copies the HTTP status or the HTTP status code, right? 200 means good, right? What I'm going to do now is I'm going to go and upgrade the control plane only, right? So this is something new with the NodePools, because now the upgrade process has this flag, -- control plane only, right? So I'm grading the control plane only now, right? We're going to wait for a while, then it's going to upgrade. If I go and show this, after a while, then the control plane got upgraded, right? Now, what I'm going to do is add a new NodePool under the same cluster with the new Kubernetes version, right? So that's a new NodePool called nodes 14.18, right, with the new Kubernetes version 1.14.18, right? Now, after this process is done, I have 2 different NodePools inside my cluster running 2 different versions of Kubernetes, right? And the reason being, the control plane, by the way, can tolerate n-2 in the minor version of Kubernetes, which means if your control plane running 1.14, it can work with 1.13 and 1.12 nodes. The other way around doesn't work. So you never can have 1.14 NodePool running on a control plane 1.13. So you always have to upgrade the NodePool, the control plane first, right? So if I show the labels for the nodes, now I have the new nodes added with the new label, right? So now I need to migrate my application. The way I'm migrating my application is pretty simple. What I did is I created a new application with a new name, my app v2. However, I left the same app. I left the same label on the application. So once the pods get created on the other NodePool, they're going to be picked up from the service that was already created, right? So, and if you look down, this is still the loop is working and it's 200 old, right? Okay, so I created the app. The pods are creating, right? The endpoints are being added to the new service. Now I'm going to go and delete the first app on the first NodePool, right? The application remains running, right? Nothing has changed from my application. Now we did full migration with a new NodePool with 0 downtime for my application, right? With the minimal risk that is there, right? So that's one way of doing upgrades. 555, right. Okay, so this is what we exactly did. The other way of doing upgrades is creating new clusters, right? So there is a new version. You create a new Kubernetes cluster with the new version. You test on that new cluster. If things went well, you change the endpoints from your whatever, load balancer, global load balancer, and so on, right? So that's the other way of doing it. Now, when to use which, right? The AZ or the AKS upgrade API, you only use it with non-mission critical type of workloads, right? Or small production clusters, right? You never use it for mission critical type of workloads, right? Because it's subject to failure. Unless you're fine with this, then you can use it, right? Now, when to use NodePools versus new clusters? With NodePools, if you notice, we went and upgraded the control plane first, right? So there is a chance that this control plane process, update process, can fail, right? If you are fine with this risk, then use NodePools. If you're not fine with the risk of the control plane failing, go for new clusters, right? So that's basically the criteria, right? I'm gonna share anything else with you because I'm also out of time, so I'm just gonna share the important parts, right? All the things that I wanted to share, but I couldn't. OK, takeaways. Use standard load balancers. Use NodePools. That's very important, right? Maintain N-1 on the minor version. So if your minor version, the current minor version, the latest is 115 from Kubernetes, stay on 114, right? That's normally less buggy, right? Unless there is a feature on 115 that you require, right? And on the patch version, so the 114.8, normally the first version of Kubernetes will be 114.0. Never use the 0.1 because it's buggy. It's 0, right? So wait for patch 2 or 3, right? So wait for the second or third patch version, right? Automate the reboots for your cluster using Cured, blue-green type of upgrades if you have mission-critical workloads, right? Now, the most important part that you're waiting for, so this is the repository. The first link is the repository where I dumped all the demos. So there are 12 demos in there with the transcript, with the slides as well that I presented now. So go and explore. It's open, open issues for me. You can speak with me there, do whatever you want there, right? Hopefully, all this session will land in the AKS best practices documentation eventually. So we're going to work with the product group in order to land these type of recommendations there. Yeah, check the AKS documentation, the Kubernetes docs, and so on. That's it. Thank you for being here today. I hope that this was worthy of your time. Yeah, thank you. Appreciate it.